Okay, everyone, welcome back from the lunch break. The next talk is from Jelma about automating Debian packaging.
Yeah, thanks. My name is Jelmer van Ooy. One of the things I've mostly been working on in the last couple of years is the Debian janitor and a sort of bunch of related software. And the janitor is basically a bot that creates merge proposals on primarily Salsa, but also on GitHub to fix sort of trivial issues in Debian packaging. And this talk is about sort of a combination of a lot of the things that I worked on there, slowly getting towards automating more and more of Debian packaging, maybe even to the point that you can generate a full package. So basically everything I'm going to talk about today is sort of driven by my work on the janitor, but the janitor is meant to sort of delight, so not necessarily surprise people by sending them really weird changes or reformatting their control files in a way that they don't want. So it's set up in such a way that it's really, really conservative. So if it's thinks a particular change might be reasonable, but it can't verify that, it'll basically just bail out and not do anything at all. But all of the tools can do a lot more sort of enthusiastic changes, and you can actually use them in that mode as well. So like there's a YOLO mode for Lintium Brush, which will basically try and make as many changes as it can, but some of them will possibly either be wrong or be very opinionated, and so you might disagree with them. My goal with all of this is not to sort of fully automate all of the packaging in Debian, because that's pretty hard. It's mostly to just make it so that for a lot of packages, a lot of the work that is easily automatable is automated so that humans can then do all of the hard work that only humans can do and machines find very hard. And most upstream projects don't actually have enough structured information to generate a high-quality Debian package because the information just isn't in the upstream, at least not in a structured way. So you can use some heuristics to get sort of close, and there's some languages like Rust that actually includes almost all of the information that you need, but for a lot of other languages that information just isn't there, at least not for a high-quality package. Like you might be able to get very close by looking at the structured info. And then the final thing is sort of like I'm mostly just targeting very simple packages, not libc, not LibreOffice. They're just going to involve manual work. And all of this, and in particular the janitor, are basically possible because of a long list of improvements that have happened to the Debian ecosystem and the upstream ecosystem over the last couple of years. So in particular, the fact that everything is now in Git just makes it so much easier to do source code manipulation, but also to find relationships between the upstream and the packaging, but also to reason about sort of changes and roll them back and forth. And just the sheer fact that everybody's now using Git, although I guess there are still some holdouts, and I'm actually I still maintain some packages in Bazaar, but there's also like Monotone and CVS and Subversion, but the vast majority of packages are in Git. So if you support Git, you can probably get like 80% of the way there. So that's really nice. And there's now a way of finding the Git repository, so VCS Git headers have made that really easy. I mentioned the variety of version control systems. I think nowadays it's mostly just either Git or not in version control. But there's still like one package in Monotone and a handful in Bazaar, whole bunch in Subversion, some in CVS. The graphs that I've got on the slides all come from trends.debian.net, which is a service that I think Lucas set up, with sort of very interesting graphs about Debian. There's also Debian upstream metadata, which is a proposed standard, but not actually accepted yet, with some metadata about the upstream that a package is based on. So among other things, it contains the repository URL for the upstream, but for example, also like the bug database URL. And being able to find the upstream URL is really useful, in particular if you want to, for example, pull in new snapshots or other things like that. And one of the things that I built as part of the janitor is a tool that can sort of generate this file with both the repository information, but also some other metadata. So for example, if you look at a random Python package, it'll actually extract a description, the repository URL, the name, etc. This all comes from setup.py. And the description actually comes from, I think, either the README or setup.py plus some manipulation. And then one of the other things is that their auto package test is much more widely adopted nowadays. So that makes it possible to make automated changes, but also then be sure that at the very least you didn't break the package in a trivial way. So in particular for the janitor, that's really, really useful. And then the fact that DebHelper is now ubiquitous, or mostly ubiquitous, is really useful, because if you want to grab a random Debian package, make some changes to it, it's really nice to be able to do that in a single way, rather than having to support sort of 3 or 4 different build systems. And the other thing with modern DebHelper is that the amount of configuration you have to do is fairly limited. So that means you don't have to generate that configuration in some way. So one of the main tools that's underlying the janitor is Lintian Brush. And that basically came out of the idea of Lintian has these messages where it actually literally says what command you should run in order to fix the Lintian issue. So what if we just take those commands and we run them for you? This is a very trivial example, but there are sort of similar examples that are slightly more complicated. And so Lintian Brush is a collection of about 150 different scripts that fix, I think, on the order of maybe 200 different linting issues. And most of them are fairly trivial. Some of them are sort of like, if the homepage URL is HTTP, let's verify that it's also available over HTTPS, and then update the homepage field to use HTTPS, that sort of thing. And yeah, this is an example code for a fixer that simply replaces extra with optional, and then reports it appropriately, honors that if there's a Lintian override, for example, it doesn't actually change anything. So that was sort of the start of the janitor. One of the other things that I found it needed to do was you run into situations where there are missing dependencies. So you get these massive build logs, and then you need to find out what is wrong. So there's a tool that can scan the build log and essentially with just regexes find the problem that's causing the build to fail. So it literally just scans the build log, finds the first line from the bottom that matches the regex, and then converts it to a more unified error. So in this case, it's Apertium 3.2. It's missing, and it's because of a pkg config file. So if you take that, let's say we're building with sbuild in isolation. We then get an error log. We scan that for the error, as I just showed. So for example, it could be a PKG config file that's missing, or it could be a Python module that's missing. We find that error, we convert it to something more generic. So like, there's a Python module missing, rather than sort of this particular string, because there are lots of different ways in which you can report that a Python module is missing. And then you convert that to some sort of requirements. Because there are different problems that can occur. They're not necessarily all, there's a Python module that's missing, or there's a C header that's missing. It could also be there's a syntax error in the C file. So we convert that to requirements, and then we try and convert that requirement into something that we can resolve using apt. So in the case of a Python package, it would be something like, let's do an apt file search for a particular path that matches a particular regex. And in that case, we would find, for example, that the Python free-blah package is missing. In some cases, you would find multiple results. So because there are multiple packages that, for example, contain a particular module or node file, and in that case, it uses the reverse builds popularity count for that particular package. So then we update the build depends to include the new package that we found we were missing, and we repeat so long as we get, basically we keep repeating this as long as we get a different error. And then eventually we get either success or we get an error that we can't either can't interpret or can't resolve. And so this is fairly effective in making sure that all of the build depends are present. Although it has a couple of caveats. So you need a lot of regexes, which is a little bit painful. You also need quite a bit of time because you're basically building the package over and over again. And you're only finding out about build depends that actually cause the build to fail. But it is fairly effective in sort of getting to a functioning package. Yeah, and this is sort of the other thing that can happen. So you scan for errors. And for example, you find an error that you can't interpret or can't resolve. And then we just abort. And then a human will have to look at it, or in the janitor's case, it just means that the package has failed. So if we now take all of these things that I just talked about and we combine them, we could actually generate a Python package from scratch. So we find an upstream release somewhere in Git and check it out. So in most cases, it would just find the latest release, switch to that. Detect the build system. So is it using Make? Is it using Python of some sort? Or Rust or Ruby or whatever. We find the appropriate metadata from the upstream metadata. So setup.py or the README even. In some cases, we'll actually scan the homepage. Find relevant WPP bugs. Determine the source package name. Create a changelog. And then we create a package based on the build system we found. So for Python, for example, using DebHelper with PyBuild. But if it's standard make, then we just rely on DebHelper and make install and things like that. Yeah, and then as necessary, that would mean creating a dist tarball using that build system that we found. Generating the appropriate build files. So in the case of Rust, that could mean generating a debcargo.toml file rather than a rules file. Generating a rules file, although using DebHelper, that's generally fairly trivial. And then creating a binary package, although in the current situation is also fairly fairly trivial. So for a Python package, it's just a single Python package. And then we use dcopy to generate a copyright file and set a bunch of other control files. So that actually gets us to a Debian package of sorts. Some of the fields will be missing if we can't actually find them in, for example, the upstream. And in a lot of cases, like, for example, we can't find the upstream build system, so it won't work. But for a surprising portion of the Debian ecosystem, this is actually enough to actually get you a package of sorts that is non-Lintian compliant. If you say wanted to package something, it would actually at least get you a start for a package, which you could then fix some things in. And then optionally after that, you can invoke debfix build to add the missing build dependencies. And there's still sort of a gap here in terms of like runtime dependencies. And then at the moment, this is supporting sort of the common language ecosystems in Debian, so Python, Maven, Perl, Node, Go, R, Octave, which I guess isn't super common, Cargo, and sort of the default configure, make, that sort of thing. Yeah, so let me show you how this actually works on on the package I was just talking about, Fabulous. Hopefully I remember the URL. Hopefully this is readable for everybody. So just running Debian -x on the upstream. It's creating a dist tarball. Looking for WMPP bugs, which apparently there isn't, or maybe they've already been archived. And now it's running as built, which hopefully will only take a minute or two. Any questions in the meantime?
YOLO option, I couldn't find it.
Sorry?
I couldn't find it for YOLO.
It's not uploaded yet. There is -- uncertain, which does the same thing.
Oh, okay. But I'm going to try. The microphone.
Yeah. So basically, what Andrew was saying was the YOLO option isn't there yet in unstable at the moment. But there is -- uncertain. So yeah, so it's done a first build, and now it's found that setup tools is not actually in the build depends. And it's going to try and use apt to find a replacement. And so now it's added a build dependency on Python 3 setup tools. And it's going to try and build again. And if this works the same way as when I tested it, it should now complete successfully. But in the meantime, I can show you what the package looks like. So this is what it generated: a changelog, a control file, copyright rules, source, upstream, and watch. The watch file is sort of what you would expect for any random GitHub package. And if I look at the control file, the order of the headers is a little bit unusual, but not incorrect. Sorry? And so, yeah, it's basically set all of the headers that you would expect based on just the upstream. And then it's also extracted the description from setup. And if you look at the actual README, you'll see that how much actual processing it's done of the README file. So it's extracted like this middle bit. to get to that description. All right, and yeah, we've just successfully finished building. So I'll just run Lintune on the outputs. It'll still be quite unhappy, but the actual errors aren't that bad. So there's no manual pages. There's some font files that get installed in the wrong location. And the copyright file is still fairly incomplete. So yeah, so that's Debian Ice, and then we could take this one step further and do this recursively. So what we just saw was we run Debian Ice and then we run Debian or debfix build after that, and we recursively add build depends for packages that are in Debian. But if we can't actually find that a package is in Debian, we could go out and we could discover where the upstream lives, and then we could run Debian Ice on the upstream location. And that's what Debian Ice -r does. So, for example, if you find that Python 3-blah isn't packaged, we can consult PyP to find Python 3 or to find blah. Figure out what the upstream repository URL is, clone that, run Debian Ice on that, upload that to a local apt repository so that when we run Debian Ice or debfix build again, we can now find Python 3-blah. And we can just do that recursively over and over again. And so this is actually mostly working at the moment for Python and for Rust, not for any of the other sort of repositories out there yet, so not for CPAN or for PHP. But for Rust, like I've managed to use this to basically package 5 or 6 Rust crates in a row. So yeah, that's Debian Ice -rx, and all of this is still very sort of experimental. Like if you actually try it, like Geert was doing this week, like it'll probably break in some unexpected way, but it's slowly getting there. So yeah, that's it. Thanks very much. Here's a list of the commands that I've talked about for reference. Any other questions?
Okay, so thank you. That's very interesting. What about the Debian roots file that you generate? Do you generate anything more complicated than just calling DH?
No, at the moment I don't. So I'll show you what it looks like. At the moment it's just this. So it's literally just determining the right argument to pass to build system. Like debhelper makes it really easy to do this sort of thing now, because you don't actually have to generate all of the other instructions. That would make this significantly more complicated. And same goes for like if you wanted to generate multiple binary packages from a single source package. Yeah, this would get very complicated and hairy, and so I haven't even gone there.
Okay, and what happens when files are installed in the wrong location? Do you generate install files, for instance? Or?
Not yet. So that I think my approach here is sort of quite similar to the janitor, where I'm trying to get it to work for sort of the common case, and the case where that is not common. Like I intend to just say like, oh, don't know, do it yourself manually, but that still means you can get some benefit in the vast majority of cases, because it is really either impossible or really hard to sort of fix it generally.
You could, excuse me when I'm monopolize the questions, you could try to find out when you have a .configure, whether there are any useful options to .configure, for instance.
Yeah, so that is sort of one of the avenues to go in, but it's I think maybe at some point in the future that would be interesting to explore. Once this actually works better, I think. So guest upstream metadata, for example, will actually parse like configure files or the configure files to extract some of the metadata. But actually, it's one of those things where if you can get it sometimes, it's nice. But if you want to consistently be able to parse configure outputs, yeah, it's going to be really hard.
So first of all, interesting thing. Can this also be used if I want to, let's say, update a Python package and it introduces new dependencies? Is there also like a command for it to say, okay, I want to update this package and then recursively try it out?
Yeah, so you can run that new upstream. That will actually pull in the new upstream version. And then follow that by debfix builds to add the missing dependencies. So there's probably a little, or there's quite a lot more work to be done there in terms of automating what that new upstream does. I think one of my backup slides actually has a, yeah. So this is the janitor is trying to do this as well. And this is the diagram for how it tries to do that. So like using VCS Watch and using the uscan, invoking debfix builds, and like this box is not very smart yet. So in particular, updating the packaging if the upstream changed in some way, or if the license changed in some way, for example. That's a really big challenge.
Okay, thanks.
One more question over here.
Yeah, what I was wondering is with what types of build systems or programming languages does this work particularly well? I don't know if you've mentioned it in the beginning. You've showed some Python build things here, but could I use this for basically getting an initial packaging for, let's say, everything that I ever wanted to touch?
So at the moment, it's got some hard-coded logic for these things. Anything else is probably you're probably gonna push your luck. Although the amount of logic for each of these is fairly limited. Like this is the amount of code that exists for Python. Like it's not super complicated at the moment, and it's admittedly also fairly dumb. So like there are probably lots of things that this will break on, and you end up with a package that almost but not quite builds. But that's probably still a good start. So.
And is the whole Python toolchain then the most mature one, or are there much differences between all the different systems that are supported?
I think Python or Node or maybe Rust are the most mature, although the Rust one is not using a DebConf. So it's generating DebCargo files, but not for the DebCargo.conf repository, so it's not really that standard.
Thank you.
Yeah.
Hi. If I experiment with it, an account or something, should I report it or should I? Which level is it? Are you happy for taking more to scale up the project? You're happy. Okay, thanks.
Yeah, bug reports are very much appreciated. The code probably needs some improvement also to sort of make it easier for other people to understand. So at the moment it's very sort of prototypey. And there are tests for sort of the periphery of Debian Eyes, but for Debian Eyes itself, there's, for example, not a lot of tests at the moment.
What would be the reference case? What is the most mature one? So, okay, this can it already do?
So Python stuff is probably what I've tested it on most.
Okay.
Yeah.
Any further questions? Okay.
Thanks.
Thank you.